All right, so for these two questions, there's a part A and a part B. So to predict the major product of this reaction, we have an alkene, which is going to end up being a weak nucleophile. And then Br2 is going to end up being a strong electrophile, because Br is a good leaving group, and it is based on the strength of the leaving group. And although bromide is not the strongest electrophile, it is strong. So what we're going to do now is identify what type of reaction it is. Well, with a weak nucleophile and a strong electrophile, this makes an SN1 reaction. Because for it to be an SN2 reaction, there has to be both a strong nucleophile and a strong electrophile. But the alkene reactant is a weak nucleophile, which eliminates it to a first order reaction. And through process of elimination, we get to an SN1 reaction. So once we go from here, what we're going to do is the alkene as a nucleophile is going to carry out what we call a nucleophile attack. So let's write out the Br2. This is what the bonds will look like. So the the alkene is going to carry out a nucleophile attack, nucleophilic attack. So they're going to attack the electrophile, which in turn is going to move here and is going to break the bond between the two BRs. Otherwise, octet would not be fulfilled. So from here, what we're going to do is, normally this would create a carbocation intermediate here once we have this nucleophilic attack, and then this bond between the two BRs is broken and the one group attaches onto this carbon. We normally would form a carbocation intermediate, but I will show you why we do not form a carbocation intermediate. So from here, we are going to form this. Well, so what happens here is this bromide loses a pair of electrons to form bonds, and this Br leaves as the leaving group, the good leaving group that it is, leaves the Br2 to separate as its own ion. And what that does is it makes bromide right here positive, because the octet is not fulfilled here as it should be. And using concepts for formal charge, we must write down the formal charge if it is not 0, and it is not 0. And if you need to work that out on your own, you can, but to prove here, it is positive 1 as the formal charge. Now, this is not a carbocation intermediate. A carbocation intermediate forms on what is called a carbon, and this does not look like a carbon. If this positive was over here, 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 and so on, it would form a carbocation intermediate, but it does not, because it is on the bromide or bromine. So now what we're going to do, so this forms from the alkene, and the leaving group is still left on its own. So we're going to write that right here. And it is negative, because once again, the formal charge, if you work it out, is going to be -1, because the valence electrons are 7 and there are currently 8 electrons. So what we do here is now this becomes the nucleophile. So what we're going to do is it's going to attack what was once the alkene. Is going to attack this compound. So it's going to pull these electrons over here in what is known as a front and back attack. It's going to pull here, and to keep the correct octet fulfillment, this bond right here has to break. So this is going to once again go onto the bromine, and thus the problem is that we can do this one of two ways. Well, it's not a problem, but we can do this one of two ways. So this is what is going to be the back attack. This is the back. This is attacking from the back side of the compound, from the back side of the positive ion. So what we're trying to do in this step, let's say, is we are trying to neutralize this atom, the bromine, because we do not want this to be positive. We want this to be a neutral atom. So we're trying to do a front and back attack to neutralize. We have a negative bromine and a positive. We can put these together and we will eventually be neutralizing the bromine. And to do that, we can do either a front or a back attack. This is the back attack. Or we can also do right here wedges and dashes. So wedges show that the compound is facing towards an object in front of a surface, let's say, and these little dashes represent that that bromine is facing behind the compound or not in front of view. So this is a backwards attack. To do a frontwards attack, we would have to attack from the front of the compound. So to show that, this is what would be the front attack. And thus the same way that we did here, this bond had to break, and now this bond has to break in order to form that neutral atom. So from here, let's draw our little arrow. So now the second step for us in this is going to be going to end up forming what we call stereoisomers. They are the same compound with the same substances, the same atoms, bonded nearly the same way, but there's a little difference. So what we're going to form here is we're going to form these two stereoisomers from the front and back attacks, two separate attacks. So here, from the backwards attack and the frontwards attack, we form these two stereoisomers. Like I said, it's the same compound. It is just, in other words, it is bonded the same way, but it is different because this is supposed to be towards the back of the compound and this is towards the front, and in this version this is towards the front of the compound and this is in the back of view. If you were to put this into one of the molecules, you could see visually how this bromine is going to be behind this one and this is going to be in front of this bromine. So major product formed from here. This is for answer number 1. And then for part B, to name the alkene reactant, which is this one, unambiguously using IUPAC nomenclature. So what we first want to do is we want to count the longest carbon chain present. So there's, let's see, 1, 2, without lifting your pen. So 1, 2, 3, 4, 5. Sorry, let me restart that. So 1, 2, 3, 4, 5, 6. So there's 1, 2, 3, 4, 5, 6 carbons present. All right, 6 carbons, and that's without lifting your pen. So if there was something to go off of here, off of the chain, that would not count. If it is not part of the chain. You have to pick the chain, or you have to pick something off of the chain, but you cannot do both. In this instance, we only have a chain. So there's 6 carbons. So that is hex. And alkenes are the strongest group. There's an alkene present that takes precedence over alkanes, which are also present. So the hex will end in ene for alkene. If it was just alkanes, it would be hexane, but it is hexene. And here, this is cyclo. And the reason why it is cyclo is because it forms not an aromatic, but it forms the carbon chain shaped like this, in a shape, rather than just a regular standalone chain. And then to number it, you would go highest priority, which has to include the alkenes. So we would start and go around this way. And so to name it, you would do 1 cyclohexene, because the alkene starts at 1, but you don't have to write the 1. You can just write cyclohexene, or you can write 1 cyclohexene. And that is all. Thank you.